what is the first step? Choose which side we're solving. Remember, we box in one side and we're not touching it. That's our answer we're trying to get to. So we have to decide which way to go. Now that doesn't mean we can't change our minds, and I will talk about what happens if you get stuck. But if I were just going to pick a side to box in to start with, which one would you box? I think the right. It's probably easier to get rid of the fractions than it is to try to turn something into them. So now I'm not touching this. I'm not carrying it down. I'm just leaving that there. I'm trying to work with the other side. Lots of options for where we could begin here. Keep your goal in mind. So our goal is this red box. I want two separate terms, okay? So what could I do with the left?
Split it into tangent t divided by sine t cosine t and cotangent t divided by sine t and cosine t.
All right, that would work. We only have a single term on the bottom, so we could separate it and put each one over the denominator. Okay, not that this makes it look super pretty, but we have two separate terms now. I'm trying to get secants and cosecants. In order to get secants and cosecants, I probably need sines and cosines to start with. What would you do with tangent? Didn't change. Okay, what about cotangent? And remember, those are the ones that I'm not giving you. You need to know those, the reciprocals as well. All right. This is kind of ugly. But what I have here is essentially a fraction and a fraction. This is like sine t cosine t over 1. How do you divide fractions? All right. I think we're actually in pretty good shape. What happens? If I have a sign on top and bottom, I could drop that out. What's going to cancel in this term? So now I have 1 over cosine t times cosine t is cosine squared t. Minus 1 over sine t times sine t is sine squared t. 1 over cosine. What's the reciprocal of cosine? Minus 1 over sine. What's the reciprocal of sine? And that is what we boxed in at the beginning that we were trying to prove. Okay? Let's just keep practicing these. Which side would you box in? First one? Alright. It's really a toss-up. They're pretty similar. So you just pick one. And we're going to work and see what we can get. Normally I tell you, look for any identities. Okay, but the Pythagorean identities require like a sine squared or a cosine squared. If we don't have identities, I say, okay, turn everything into sines and cosines. But it is already sines and cosines. If we have things add together, I tell you to get a common denominator, but I don't really need that here. So we're kind of stuck. There's no obvious starting point, right? Look at our goal. What am I trying to get on my denominator?
1 minus sin x.
It's a fraction. Is it legal to just multiply by that, as long as I do it on both the top and the bottom? Okay. Multiplying by a conjugate. We saw that a lot with radicals before. So we are just going to multiply by the 1 minus sin x on top and bottom. Let's see what happens. On the top, if I FOIL, I get 1 minus sin x and plus sin x cancel. Minus sine squared x. I don't think I want to distribute on the bottom because I'm hoping, I want 1 minus sine x, so I'm hoping I can make that cosine disappear. Now what?
The top turns into cosine squared.
Yeah, 1 minus sine squared x is cosine squared x. Is that helpful? Now I can cancel a cosine, and I get cosine x over 1 minus sine x. So that's another new strategy, just multiplying something else in. All right. What do you want to box in?
The right side?
I heard right, I heard left. Does it matter? No, we're just going to pick one. So which one do you guys want to go with?
Right side.
All right. 1 plus sine x, there's really nothing I can do there. Is there anything I can do with cotangent squared?
Turn into tangent squared. I mean, cosine over cosine.
Okay. Is that what you guys want to do? Change it to cosine squared x over sine squared x? All right. Now what? Multiply by the reciprocal. So I have okay. How does that help me? Look at our goal. We want a plain sign on top, which we have in this jumbled mess. On the bottom, I don't want cosine. I want cosecant. How can I get rid of cosine squared? Cosine squared would be 1 minus sine squared x. Yeah, how do we factor the bottom? So that gives me sine squared x over 1 minus sine x. Look at our goal. We want sine x over, what was it, cosecant x minus 1? So we're not there. It at least has the right number of terms in top and bottom now. We're closer. Does anyone see how we could get there?
Sine squared divided by sine.
What would happen if you divide it by sine? Or essentially what he said is, if you multiply it by 1 over sine, on top and bottom. What's sine squared x over sine x?
Sine.
On the bottom, 1 times 1 over sine. What is 1 over sine? 1 over, would be the reciprocal, minus, what's sine x over sine x? 1. And we got it. Now, did we take the easiest path? No, probably not. Did anyone have a different idea of what we could have done with this cotangent squared? You could have changed it to cosecant squared minus 1, and then factored and gotten it from there. But what do we do? Like, it was pretty smart to take it times 1 over sine, but what if we didn't think about that? What if we got here and we were just totally stuck? Okay, I don't want you to just go back and erase your whole problem and start over. That's not what I want. An option, if you get stuck, you can say, okay, I need to change my plan. You can box in the side. Say, I worked this as far as I can. I don't know what else to do. I'm going to box that in. And then you could come back and say, okay, I can't really prove this, but could I work with this side and try to get it to be the same thing? Okay, so that's an option if you get to that point when you are stuck and you just can't figure out anything else to do. So you could have said, okay, cosecant is 1 over sine. We have a fraction and fraction, or what you could do is just multiply by what's on the denominator to cancel that fraction. And then on the top you get sine squared x. On the bottom you get 1 minus sine x. And is that the point we work the other side to? Yeah. And so then you could box this in and say, okay, I couldn't prove the original, but I worked both sides and I got them to be the same thing at the end. And that is also okay. All right, so if you get stuck, don't erase everything. Go work the other side and see if you can get it to the same point. Any questions there? Let's try another one. Alright, neither side is beautiful. Which one do you want to try to box in? Now, if we can't get it, we now know we can come back and work this side. But if I box in the left, any thoughts about what we could do on the right-hand side? Okay. When you say split it up, are you saying like make each one over the denominator or like factoring? Okay. So we really can do either. So if you put each one over the denominator, we end up with 3 different terms. Is that where we are trying to go? I still want just one big fraction, don't I? So not that this is wrong, but it might take us longer to get there because we're kind of getting further away. So what if we don't do that. What if we instead say, okay, let's keep the one big fraction. Cosine squared minus 2 cosine plus 1. What could I do with that? What if it had been like x squared minus 2x plus 1? Oh, I'm going to go tell Mrs. Keller right now. You guys don't know how to factor that. What would it break into?
Cosine minus 1, cosine minus 1.
Yeah. X squared would just break into x, multiply to 1, and add to negative 2. That's all we're doing, but with cosines. So cosine squared would just break into cosine. Multiply to 1 and add to negative 2. So negative 1, negative 1. Okay. Nothing's going to cancel out as long as I have this sine squared on the bottom. What could I change sine squared to? And it had a negative out front. I'll just keep that out for a moment. One minus cosine squared would be a difference of squares, right? 1 minus cosine, 1 plus cosine. We're trying to get something to cancel it. Now this negative, you could distribute it into one of the parentheses. It wouldn't go into both, it's just one. So if I just multiply it through this one, that's a negative 1 plus cosine. Negative 1 plus cosine, isn't that the same as cosine minus 1? So we can cancel one of those. All right, look at my goal. I want something minus something on top, something plus something on the bottom. I'm kind of close, but my functions are off. Do you have any ideas on how we might get there? Okay. I think we could go with your first one. What would happen if we multiplied by cosecant on top of that? It's closer. I now have the minus cosecant. I have a plus cosecant. I'm missing the cotangents, aren't I? So I want some of these cosecants, but not all of them. What could I change cosecant to? Okay, so if I multiply those, I have cosine over sine, which is cotangent. This would be a cosine over sine, which is also cotangent. Is that equivalent to what we wanted? Just has the terms flipped around. Now, the problems that we're doing, guys, I'm not pretending that we took the shortest route to get there. I'm just trying to go with whatever options are given to us, okay? So don't think every problem has to be this long, or if you had a different thought, don't think that that didn't work, okay? There are lots and lots of ways to get there. We just have to find one option. And what you do, I mean, largely depends on which side you start with and where you begin, which route you go. But we were able to get there. If we had gotten stuck and we couldn't, maybe we didn't think about multiplying by 1 over cosecant, what would we have done instead?
Switch to the other problem and try to get the answer we got.
Exactly. Switch to the other side and try to simplify the same. All right. I have lots of examples today, so we are going to work as many or as few as needed. How are we feeling so far? Bad? Okay, so we're not done. We need to do some more. All right. Let's try this one. All right. Which side should we box in? Okay. What do we have to add or subtract fractions? Common denominator. Okay. I don't have much space to write this in, so I'm going to copy it down to show you what I'm doing, but you guys don't have to rewrite this line. So the first fraction, I'm going to have to take times 1 plus cosine x on top and bottom. This one I'm going to have to multiply 1 minus cosine x on top and bottom. So if I start multiplying this out, I get sine x plus sine x cosine x. What's the denominator if we FOIL? This one, sine x cosine x. Minus sine x cosine squared x. So if I want to subtract, I can change this to a plus and run a negative through. How does that help me? We're doing pretty good. We don't have two separate fractions anymore. Look at our goal. I want things multiplied together. So that means we have to factor. What could I factor out of the top? That would leave me with the 1 plus cosine squared x, which looks promising because I want that in my answer. On the bottom, what is 1 minus cosine squared x? What happens? One of the signs cancel. What you really have right now, you can write it as one big fraction, or you can think of it, we talked about yesterday, when things are multiplied, you can kind of separate them. I have a 1 over sine times a 1 plus cosine squared. What is 1 over sine? And that gives me cosecant times 1 plus cosine squared. I feel like maybe we took a more direct route that time. Seemed a little less confusing. How do you guys feel about that one? Good. Good? Let's do one more together, okay? And then I'll let you guys try some and see where you're getting stuck.
That one.
Yeah, no, good.
Just wait till I blow up.
So, Zach, which side looks easier?
Probably the left side.
Okay. All right, where can we go?
Probably simplify.
Okay, how do you want to simplify first? What are you thinking?
I'll probably will simplify.
Okay, start distributing. All right. We have two things added now. It's closer. What do I need to do next? Okay. Cosecant is 1 over sine t. So when you multiply these, you have cosine t over sine t plus sine t over sine t. What is cosine over sine? What is sine divided by sine? And we got it. All right. Started us on the right path. Good choice. Good choice. All right, so on classroom, the next, it says 5.2 day 2, I believe.